getting started, ruminants have obviously very unique digestive tracts that are specifically built for forage-based diets. So they are built to break down and use for fuel fibers that monogastric animals like poultry and swine and humans can't do a thing with. So they have really specialized and unique digestive systems. So as ruminant animals, cattle really only have one true stomach. And then the three other compartments that are the ones that break down, that have specific roles that break down the fiber that they consume. So the first two compartments of the ruminant stomach, so to speak, are the reticulum and the rumen, or the reticulorumen. And you can see here on this diagram that the two put together are really quite large, and they kind of wrap around. When we think about how they are situated in the animal, they kind of wrap around behind all the other stomach compartments here along the left side of that animal. So once food has been ingested, it's briefly chewed and mixed with saliva, and then it's swallowed, and then it's moved down the esophagus into the rumen. And the rumen is the largest stomach compartment. And this is really the part that is the one that does all the heavy lifting for the digestion of fiber. And the way it does it is through fermentation. So in the rumen, there are billions of bacteria, protozoa, and fungi that call the rumen home. And these are the microbes that break down the fiber so that the ruminant animal can use that for fuel. Now, the rumen is made up of two layers. There's the epithelial layer and the muscular layer. So the muscular layer is kind of the outside of the rumen, and it's the layer that's responsible for rumen contractions, for moving the rumen, for helping with sort of that physical breakdown of the feed. And then it gives support to the epithelial layer. The epithelial layer is the inside of the rumen, and it is the part that is the most involved in absorption of nutrients. So the epithelial layer is covered with, again, hundreds, thousands of tiny projections called papillae that increase the surface area of the rumen and allow for the absorption of those digested nutrients from the diet. Now, as I mentioned before, billions of microbes call the rumen home, and that's because the rumen's environment really favors the growth of these microbes. So it's these microbes that ferment feed in order to produce nutrients, as I said. So the rumen absorbs most of these nutrients through the rumen wall, through those papillae, into the bloodstream, where they're then transported throughout the body as they're needed. Now, the reticulum is kind of a pouch-like structure, and it's located in the forward area of the body, kind of a little bit closer to the heart there. The tissues in the reticulum form a network that's similar to a honeycomb. So it sort of looks a little bit like a honeycomb on the inside. And these tissues are also covered in papillae. So there is a small tissue fold that lies between the reticulum and the rumen, and they are talked about separately, but they aren't really actually considered to be separate compartments. So we do sometimes put them together as kind of the reticulorumen when we're talking about that whole big compartment. As particles leave the rumen, they're shunted into that part, into the reticulum, and the reticulum helps to collect them and move them into the Omasum. So together, the rumen and the reticulum have a capacity from anywhere between 50 to 120 liters of food and fluid in mature ruminants. They can be enormous. So again, saying it for a third time, summarizing and just kind of highlighting the importance of this, and this being something that we're going to come back to throughout the course of this presentation, the environment in the reticulorumen is, again, perfect for the growth and the proliferation of microbes. The temperature is kept at a steady state, right around 39 degrees Celsius body temperature, and the pH is maintained at a steady level, all to help support the growth of the microbes that break down fiber. And we'll talk a little bit more about how it's kept that way in a few slides. So now the Omasum lies between the reticulum and the abomasum. So it's the next step in the digestive process. The omasum is a globe-shaped structure that contains leaves of tissues attached to the wall, kind of like the pages in a book are bound to the spine. And those are called laminae. Now, these laminae are then further covered in papillae. So we talked about how the rumen is covered in papillae, and that really increases the surface area for absorption, but the omasum kind of does it on a double level. It has the laminae, and then the laminae are covered in papillae, and that really helps it perform its number one function, which is absorbing water from the feed that's being eaten. So when feed leaves the reticulorumen, it's anywhere from like 85 to 95% water. So it enters the omasum, and the omasum takes almost all the water out of it. That is its main job, is getting rid of the water in the digesta. And then these papillae absorb the water and then help to move feed out of the omasum and into the abomasum. So the abomasum connects the omasum to the small intestine and then to the rest of the digestive tract. The abomasum is the only compartment that is lined with glands, and these glands secrete really highly acidic gastric juices like hydrochloric acid and other digestive enzymes. And so it's acid digestion rather than microbial fermentation that takes place here in the abomasum. And that's why the abomasum is sort of the most similar to the human stomach. And this is why in our very human-centric way, we'll call the abomasum the only true stomach that ruminants have. The pH of the abomasum tends to float around about 2, which is incredibly acidic. And it's this acidity that kills the rumen microbes that have come along with the feed and the digesta, and begins that sort of initial digestive process. And then the enzymes come in once the microbes have been killed, and they're what start breaking it down into microbial protein, which we talked about a couple weeks ago, and other things like that. From the abomasum, the digested food moves into the small intestine and the rest of the digestive tract, where it's then further broken down into nutrients, and those nutrients can be absorbed by the animal. Overall, though, the rumen is really the main focus of the ruminant digestive tract, right? And I believe I said it a couple weeks ago when we had this when we did our previous presentation, but I'm going to reiterate this point. You know, we often say that as ruminant nutritionists, we are more focused on feeding the rumen than we are the animal. And that, again, is because the ruminant digestive system truly allows cattle to make use of feed in ways that monogastric animals simply can't. And that's why we can feed ruminants a lot of the feed that we do. And so when you take care of the rumen and all the microbes within it, then the rumen takes care of providing everything else that the ruminant animal needs. And so we feed the rumen to feed the cow. Now, we've talked a lot about how the rumen is specially designed to break down fiber, but what is fiber? In this sense, fiber is defined as carbohydrates in the diet that are not digested by mammalian enzymes, but are digested by rumen microbes. And fiber can be broken down further into sort of several different fractions of fiber. And these are called cellulose, hemicellulose, lignin, and soluble fiber. Now, when we send a feed ingredient sample to the lab, we see fiber represented a different way, and it gets a little bit confusing. But when we get our samples back, we'll see fiber represented as either neutral detergent fiber, or NDF, and acid detergent fiber, or ADF. And these two fiber fractions contain those hemicellulose, cellulose, and lignin ones that we talked about on the previous slide. So NDF is the fiber that is insoluble in neutral detergent when they test samples at the lab. So a sample arrives, they grind it down really fine, they mix it with a neutral detergent, and everything that's left over is neutral detergent fiber, or NDF. Now, NDF represents all of the plant cell wall material, and it's only partly digestible by ruminants. So they can digest it, they can make use out of it, but not all of it. And so as NDF content of the diet increases, feed intake tends to decrease. And this makes sense when you think about it, right? As the rumen fills up with NDF, which again is only partly digestible, it takes up space, it makes the animal feel full, and it prevents them from eating more. Now, similarly to NDF, ADF is the portion of fiber that is insoluble in acid detergent when they test the feed samples. Now, where NDF is partly digestible, ADF is pretty much completely indigestible, completely unusable by the animal. So it's the part of NDF that is not usable, and we call that the ADF. Even in ruminant animals, even though they are specially designed to digest fiber, they just can't do anything with this fiber. So therefore, ADF tends to be negatively correlated with the digestibility of a feed ingredient. So typically as ADF content increases, feed ingredients become less digestible and less useful in the diet. Now, effective fiber. This is where it gets really, really interesting, especially when we're talking about the effects of fiber when it comes to ruminants. This is the really cool part of fiber. Energy and protein are obviously the major focus of a veal feeding program, and for good reason, right? You know, we just spent a webinar a couple of weeks ago talking about them. But fiber is absolutely another essential component that producers really need to consider when they're feeding their veal cattle. Now, we discussed NDF and ADF, and those are sort of the chemical fractions of fiber. So when we take fiber, we break it down in a lab, those are the chemical components of fiber. And animals do have requirements for those chemicals within their body. But in high grain diets like veal cattle diets, it's actually fiber type and fiber length and the physical form of the fiber itself that actively really impacts cattle health and productivity. So fiber typically tends to be more coarse and a little bit less dense than other feed components, right? So if you grab a handful of whole corn, how heavy that is in comparison to a handful of straw. So it's less dense. It doesn't tend to bring as much nutrients. So again, when we're thinking about, you know, wanting to feed veal cattle for gain, and we're thinking, well, I should be feeding corn and protein and this really good dense feed, why am I feeding fiber? It's more related to the physical makeup of that feed than it is to the starch or the protein or the chemical components that other feed ingredients bring. So effective fiber is what we talk about when we talk about the physical characteristics of fiber in a veal diet. Effective fiber is usually expressed as physically effective NDF. So you might see it written down as PENDF or ENDF, but that's the physically effective fiber that we're talking about. And again, this is the portion of the NDF fiber in the diet that stimulates chewing and salivating in the animal, and rumination and rumen motility and movement and all of these kind of physical things that are really desirable when we think about the health of the animal. This fiber really has actual tangible physical effects within the animal's body. And so what are these effects then? We talk a lot about how the rumen is designed specifically to break down fibers, but is it necessary for it to do that, right? You know, people drive really fast, sporty, or cars that are built to go really fast and sporty and drive on racetracks all the time, but they don't necessarily always drive them on racetracks. So is it, you know, even though the rumen is built to digest fiber, is it bad if it's not doing that? You know, we look at the Veal Cattle Code of Practice. It explicitly states that offering fibrous feeds that increase chewing activity and the time it takes to consume the ration is a really good strategy to improve health and welfare outcomes in veal cattle, right? But then, so is it bad? Like if we're just improving health and welfare, is it bad if we're not giving the rumen fiber? You know, these animals, they're adapted to a high grain diet, like we've said. So, you know, besides being a relatively cheap and fairly available feed ingredient in the grand scheme of feed ingredients, why is fiber important, right? We just said it's not as dense as other feed things. It doesn't maybe bring as much in terms of energy and stuff to the ration, but what is it doing? Why are we spending an entire webinar talking about fiber? So the first effect that physically effective fiber has in the diet is one that you've all probably heard of before, and that is that it provides a scratch factor to a diet. And I think people talk about this all the time, right? So Rumen epithelial tissue is a lot like our own skin. Like this is epithelial tissue as well. So the two are very much related. It's constantly regenerating, sloughing off old dead skin cells, old epithelial cells, because new ones are constantly growing, coming to the surface and replacing those dead ones. It's always cycling. But just like our own skin, every now and again needs help exfoliating or, rubbing off or things like that as those skin cell dies, so does the rumen epithelial tissue. If it doesn't have that physical abrasion to help those dead cells slough off, then those dead skin cells stay on the papillae, they build up on the surface of those papillae, and they form a really hardened keratin layer over the tops of those, almost like little helmets. And this is called ruminal parakeratosis when this happens. This layer, this keratin layer, negatively affects the papillae's absorptive abilities. They can't absorb nutrients nearly as well through that layer. And because of that, it typically decreases feed efficiency and the rate of weight gain and performance of veal cattle. This is a disorder that if it does go on long enough, if the situation does get bad enough, it can actively damage the rumen wall, and it can be very difficult, if not impossible, to reverse. So it's really important, just that physical abrasiveness on the inside of the rumen to help scrape those dead cells off. Now, this idea of feed efficiency, though, isn't just tied into the health of the rumen tissue, as is in the case of parakeratosis, but it's also tied into the function of the rumen itself, obviously, right? And this is the second way that physically effective fiber actively affects the ruminant animal. So, relatively speaking, longer fiber helps to form, and I mean, I say longer because it's longer than the grains of corn and the protein pellets that we typically feed veal cattle. So longer fiber in the rumen helps to form the rumen mat that is essential for proper rumen function and nutrient digestion. So particles that are bigger than just 1 millimeter in size cannot leave the rumen. So unless it is 1 millimeter or smaller, it's staying in that rumen. So because of this, and because fiber can take longer to break down in the rumen than other nutrients do, fiber helps to decrease the speed with which feed passes through the rumen, and it helps to increase rumen motility. Now, obviously, we don't want feed hanging out in the rumen forever. We want to make sure that the animals are always eating and they're eating as much as they can. We also don't want the feed to be flying through them. If it is moving through them quickly, then the microbes don't have as much time to sit with the feed, digest into the feed, really get into the different ingredients and break them down. So again, it helps to increase feed efficiency because the rumen just has more time for the bugs to get in there, work, break down the feed. And that rumen motility of cycling the fiber around, forming the mat, keeping things rumen, like moving in the rumen, again, helps to work that muscular layer, right? That supports the epithelial layer, and keeps things moving. And again, the more stuff moves around, the more microbes can get into different places. It's always moving new feeds, new ingredients, new digesta in for the microbes to get into. And again, then this also helps the movement, the feed move out at the end of the day. Once it is broken down small enough, a good healthy rumen constantly moving is also going to help move the food onward throughout the digestive tract. So the final thing that physically effective fiber in the diet affects in the ruminant animal is rumination itself. And through rumination, saliva production. And we've talked a little bit, and we've talked a fair bit about saliva so far, but never really why it's so important. And this is the part that really dovetails quite nicely with really the biggest reason why we should be feeding fiber to veal cattle. So more fiber in the diet means more ruminating, as fiber needs to be chewed and needs to be ruminated more than concentrates. So as we all know, rumination is the process where newly eaten feed that's been kind of briefly chewed and swallowed is then returned to the mouth for further chewing. So this rumination process helps to break the feed down into smaller pieces, which then increases the surface area of those feed particles, making them more accessible to the rumen microbes. So as a result of increased rumination, the more times an animal regurgitates, chews, swallows, brings it back up, chews, swallows. The rate of microbial digestion also increases because, again, we're increasing that surface area. The microbes are able to do a lot more with the feed. Now, this increased rumination also means more saliva production, right? We think about it even with ourselves. When we're chewing food, when we're eating, saliva is produced. Just, not only does it help, there's enzymes in the saliva that help break down the food, makes it way easier to swallow as well. And it's the exact same thing in the ruminant animal. So this saliva is produced and then swallowed back down into the rumen. And it's this saliva going into the rumen that's really important, and why chewing is really not just for the mechanical breakdown of feed, but for the chemical breakdown of feed as well. So to make a long story very short, saliva acts as a buffer to acidity in the rumen. And this is really why saliva is so important. And this saliva production is really the key to this feeding of fiber. So saliva contains sodium and potassium salts that act as buffering agents against acidity in the rumen. And it's these buffers in the saliva that help to stabilize the rumen pH at levels that are beneficial to rumen function and rumen microbes, like we talked about earlier. When we talk about how the rumen is constantly kept at a good pH level for rumen microbes, it's because of saliva production. And it's because of the swallowing of saliva that helps with that. And in fact, this is so well documented in literature, and I think this is really interesting, the link between physically effective fiber, PENDF, saliva production, and rumen health and rumen pH. They're so intricately linked that pretty much any ration balancing program or any sort of predictive modeling program, if it is trying to predict what rumen pH is going to be, that model will drive it directly off of the physically effective fiber levels in the diet. That's how closely related they are. Pretty much every modeling program will relate the two together like that. So really, sufficient physically effective fiber in the diet is critical in stimulating enough saliva production to keep the rumen pH from going below acceptable levels to maintain a healthy rumen function. So earlier, again, when I spoke about the rumen, I said that usually the rumen is maintained as the perfect environment for microbes to thrive. And we now know that that's because of saliva production and the buffering that saliva offers. And that is true most of the time. When the rumen is not functioning properly and the rumen environment is not maintained perfectly, this is when it can lead to ruminal acidosis. And this is really the biggest thing that we talk about when we talk about why feeding fiber is so important. So rumen acidosis is considered to be the most important nutritional disorder of veal and beef animals all around the world because it has significant economic and welfare implications on the farm. It's that important. It is the #1 biggest nutritional disorder that we talk about. How does it happen? What is the mode of action here? We know that obviously the rumen gets acidic, but why? When easily digestible feeds, such as corn or pelleted supplements like we feed to veal cattle, enter the rumen, the animal doesn't have to chew them nearly as much to break them down, which means less saliva production and less rumen buffering capacity. Furthermore, though, these kinds of feeds, unlike fibers, when they're broken down into very acidic end products. So we spoke about it a couple weeks ago, but we talked a little bit about volatile fatty acids kind of being the main energy source for the animal that the rumen produces. VFAs, these volatile fatty acids, are what are produced from grains and proteins, and it's right in the name, right? Acids. These are acidic end products. So not only do these feeds get broken down quickly, they don't need to be chewed as much, there's not as much saliva produced, they're also broken down into acidic compounds. So as much as they're great for the animal in terms of energy production, body function, growth, things like that, they don't help us in terms of rumen environment and rumen pH when they're fed at such high levels in veal diets. And this kind of becomes a bit of a vicious cycle. So cattle have a very specific balance of microbes living in their rumen. And at any given time, they can have both, quote unquote, good microbes and quote unquote, bad microbes in the rumen. And when rumen conditions are right, the good microbes thrive. But when these conditions change, these sort of good microbes become less effective. They might even die. And this leaves room for the bad microbes to grow. And it's these bad microbes that produce more acid. And again, that makes the pH fall even further. The environment becomes more acidic. These, kind of bad microbes love acid. They grow even better. The good microbes do even more poorly. And it just, again, sort of becomes this self-fulfilling prophecy. And it just kind of perpetuates the harmful cycle of acid production in the rumen. Now you might be thinking, Holly, you said it yourself. These cattle, they're adapted to high grain diets. Besides, I don't feed any fiber right now and my veal cattle are fine. They're totally fine. I don't feed fiber and they're doing just fine. And that might seem to be true, but acidosis can come in two different forms. It's kind of like the tip of the iceberg scenario. There's acute acidosis where we actively see that the animal is obviously ill, actively ill, not doing well. But then there's subacute acidosis or subacute ruminal acidosis. We call it SARA, is what we refer to it as. And this is not always obvious within a herd, but it can have serious consequences in terms of performance of the animal. So SARA, while maybe not quite as serious as like acute acidosis, SARA can still reduce digestion, reduce feed intake, reduces energy output from the rumen, and it can result then in reduced performance and weight gain. It's kind of like the difference between sort of having a bit of a stomach ache and like, oh yeah, maybe I just won't eat as much, and then you don't feel quite as well because you didn't eat as much or you didn't eat as well, as compared to having an actual stomach flu. You're still not doing great with a sore stomach. So animals may seem to be adapted to a high grain diet to a certain extent, but it can kind of be like walking a tightrope. It's a very fine line to be walking. Another way to think about it is sort of like driving without a seatbelt. You might be fine most of the time. 9 times out of 10, you get to your destination. It's not a problem. But that seatbelt is a really excellent insurance policy for when something does go wrong and for when something does happen. That's kind of how we think about fiber in a diet and what fiber can do to stave off acidosis or subacute ruminal acidosis. If left untreated, if SARA gets out of hand, and even if it doesn't, even if it's just allowed to sort of stay within a herd at a subacute level, SARA can still lead to laminitis, can lead to liver abscesses, reduced feed intake, as I said, things like sudden death syndrome, off feed syndrome, and it can even play a role in clostridial infections as well. So all of these conditions are chewing away at your bottom line, eating away at your bottom line. It is incredibly difficult to nail down a specific dollar number when it comes to cost. Every researcher has got different numbers and different things to look at. There's so many moving parts. I wish I could give you a specific cost per head per day of what SARA costs, and I can't, but we do know that there are direct costs in terms of vet bills, decreased feed efficiency, buying more feed, things like that, and then indirect cost in terms of lower carcass grades, increased carcass trim, things like that. So you really can't afford to overlook acidosis in your operation. So how much fiber do we feed then? We've talked about what the rumen does, what it's designed to do. We've talked about, the importance of fiber in a diet. We understand why we want to avoid acidosis. So now what do we do to avoid it? How much fiber do we feed? Studies have shown high energy finishing diets should contain 8% physically effective NDF. This is the level that's necessary to keep rumen pH above 5.7. 5.7 is kind of considered the pH threshold cutoff where dry matter intake is really dramatically reduced in cattle. So this is why they've set it there. But we also know that the chemical fiber fraction is only part of the picture. So we know we want 8% physically effective NDF. We also want to talk about the form of that fiber. Like we said, this is where effective fiber is cool. It's that physical form of the fiber that we're worried about. So this means that when we're feeding fiber, we don't want it to be chopped to any less than 1/2 inch. So about 1 centimeter in length. maybe even a little bit longer if you can, but definitely not less than that. Anything less than 1/2 inch in particle length just is not going to have the same capacity to stimulate chewing behavior as longer fiber sources. So at the end of the day, nothing less than 1/2 inch, maybe longer if you've got it. We don't want to go too long. There is a sweet spot. Too long and it's going to be a little bit too bulky. They're going to sort through it. They might not, animals might not want to eat it at all. But again, certainly not less than 1 centimeter. Clean, good quality straw is considered to be the best fiber source, the best fiber ingredient to chop down and mix into the feed. If you don't have straw, a good quality hay, you can do that as well. But straw is kind of considered to be the gold standard when we talk about it. At the end of the day, any fiber is better than no fiber. I'm not going to discriminate, but straw is considered to be the gold standard. When we talk about how to incorporate it into your ration, it has to be incorporated through the feed. So again, studies have shown that bedding with straw, hoping the cattle sort of eat the bedding and they get their fiber through there, that doesn't work. And that doesn't work for a multitude of reasons, whether or not that's because the straw gets soiled pretty quickly and the cattle don't want to eat the soiled straw, whether that's because it's not processed well enough, it's too long, the cattle don't want to eat long fiber, whatever the reason is, it doesn't tend to work. And so we really encourage that if you're going to feed fiber, it be fed through the mix. Best way to incorporate it is to chop it, mix it in with your TMR. To get to that 8% physically effective fiber level in the diet, typically that means anywhere between 2 to 5% of your total final mix should be fiber of some kind. So anywhere of like I said, 95 to 98% of the mix is grain, corn, and pellet, and then the rest is fiber. And that gets you to sort of that sweet spot. If you can't incorporate the fiber into the final mix, then maybe look at providing it either in its own feeder that's up off the ground to prevent contamination, or potentially even top dressed on top as best you can, but definitely through the feed if at all possible. Now, there are a lot of other practices that you can implement to help control rumen pH as well as feeding fiber. I really want the focus to be on fiber. These practices should complement a fiber feeding policy on your operation. They don't necessarily replace it. But if for some reason you just absolutely cannot get fiber into your diet, these are some things that you can do to help control acidosis as well. But again, these are complements to fiber feeding. Fiber really is the take-home message being so important here. So here's a great list, like I said, of some of the other factors that go into managing rumen pH. At the top of the list, as we talked about, so obviously particle size of the diet, the bigger tends to be the better, but we know that we're feeding corn and pellet, so it tends to be what it tends to be. Grain processing, again, not as much of an issue on the veal cattle side of things as we tend to feed whole corn, so we're not really worried about, really finely rolled corn or things like that. Whether or not you're feeding an ionophore of some kind or a buffer in the pellet like bicarb or something like that, those can go a long way to helping as well. And then at the bottom of the list, we get into sort of the management recommendations and the management side of things. And this is where when we talk about managing veal cattle, it should be boring. Managing your herd should be boring. The same time, consistency goes a long way towards making content, healthy animals. Feeding at the same time every single day, feeding more frequently throughout the day. If you can feed maybe a few more meals throughout the day or encourage them to eat a little bit more smaller, more frequent meals throughout the day. Preventing feed sorting so that every single bite of feed they take is the same. All of these things can help maintain healthy rumens. So then things to look for to know whether or not you need to increase the amount of fiber you're feeding. not simply feed fiber, increase the fiber that you're feeding, because you should be feeding it. Some of the things that you can look for in your herd to see if you need to be increasing that level, things like reduced feed intake and weight gain, poor body condition, lame animals. So in the absence of infectious hoof disease or something like that anyway, we know that acidosis can predispose animals to laminitis, can help cause laminitis. So if you have a higher incidence of lame animals in your herd, abnormal oral behaviors like tongue rolling or sucking on inanimate objects, these are things that might indicate that you need some more fiber in your diet. Seeing large particles or whole corn in the manure, that's a sign that the rumen's not working the way it should be. It's not breaking down the feed the way it should be. So things like that. Loose or variable manure. In more extreme cases, you might see sort of like soft, gray, bubbly manure. That's a real, bubbles especially are a real dead giveaway of acidosis. So that's something to look for. And then as acidosis gets more severe, as we start to move maybe out of the subacute stage, we'll see things like poor rumination. So they won't be bringing feed up as much, depression or lethargy. They'll look uncomfortable. They'll kick at their abdomen. They'll swish their tail, look generally uncomfortable, rapid breathing, elevated heart rate, bloat. If an animal's bloating, something is wrong in the rumen. Something's going on in the rumen. So bloat's a really big sign. Or again, if you have a history of liver abscesses at slaughter or on a postmortem or something, that might be something else to look into as well. So one quick way, if you want to evaluate the amount of physically effective fiber in your ration, if you've put some in, you want to know what level am I at, how good of a job am I doing, talk to your nutritionist about getting a Penn State particle separator test done on your feed. This is a really fast and a really practical tool that can be used to estimate the physically effective fiber in your TMR. So essentially, what happens is your nutritionist will come along, they'll take samples of your TMR from all down your bunk, they'll put it into the top sieve, this big one up top here. All those kind of levels stacked together, they'll shake it a bunch. All of the feed will filter down. And then what they'll do is they'll take those top 3 sieves worth of ingredients, they'll express those as a percentage of the whole sample that they took, and then multiply that percentage by the percentage of NDF in your feed that they know. So they will have to send a sample off to the lab to get the chemical analysis of the NDF done. But once they have that, they can take the value that they got from the Penn State particle separator, multiply it with the NDF in the ration, and that tells you how much physically effective fiber you have. Make sure when you talk to your nutritionist, sometimes with feedlot diets, given how small the particles can be overall, because it's such a high grain content, sometimes we'll only take the top 2 as compared to the top 3 to give us a better idea. But just talk to your nutritionist about that. They'll know a bit more with your specific diet, what they should be doing there. So to summarize, give you some take-home messages. Maintaining rumen pH is important to overall cattle health and productivity, period. The rumen is the big driver, and keeping that pH at a good level is critical. Acidosis then, because we know the rumen pH is so important, acidosis is the #1 most important nutritional disorder of veal animals all around the world. And fiber is the way to fight it off. So always offer a source of fiber. Do not rely solely on bedding for fiber. Straw is the best fiber to offer if it's available, chopped to no less than ½ inch in length, but other fiber sources are acceptable if that's what you've got. I'm not going to make you go out and buy straw if you've got perfectly good hay, but straw, as I said, golden standard. Evaluating and monitoring physically effective NDF is one important aspect of reducing the risk of acidosis. And finally, although it's less severe than acute acidosis, and although we may not always notice it physically on farm, subacute ruminal acidosis is understood to be prevalent in finishing cattle diets. It is almost a given, and it is thought by researchers to be more costly to the industry than acute acidosis. So it is serious. And that's why we want to feed fiber. That said, I don't just want you to take my word for it, and I'm sharing this with permission. This is a text message that I received unprompted. I did not ask for this. This is a text message I received from a producer that I work with. Over the summer, we had discussed adding some fiber into the ration, talked about getting that done, and they did decide to go for it. And they sent me a text the other day and they said, also, I thought I would let you know, since adding hay to the diet at 2%, because they had hay on farm, and like I said, fiber is better than no fiber, added hay to the diet at 2%, what a difference. And I said, that's fantastic. What is the biggest difference that you've seen? Better weight gain amongst all of the calves, where before there were some poorer doers. And they're very excited. Anytime I feed or push the feed in, they rush to the bunk. I'm happy with hay. I'm not sure I want to try straw. That's fine. We're having great results with the hay. This is the mix. They sent me a picture of the mix that they've made. They've got, you know, again, some longer fibers there too. But at the end of the day, this fiber in the diet, better weight gains amongst all the calves. We're feeding less energy dense feed and seeing better weight gain because the rumen is more efficient. It's doing its job. It's breaking down the feed better. The cattle are healthier and they're doing a lot better. That is it. Is there any questions?